So here you're being asked to apply the derivative rules to functions where you know they're derivative functions, but you don't know how they were gotten. So it's kind of like using the rules in a context where you're unfamiliar-ish with the functions you've been given. So it's not too bad, but we just need to be careful. So here we're given a function. All right, let w of t be 3t to the t minus 2 arc cosine t. So what we actually see here is that, and this is definitely part of the problem, is to notice, all right, 3t to the t, that's really 3 times r of t. And then the minus 2 arc cosine t, all right, that's really, this negative 2 times s of t. And so here, since I wrote it like that, it's a little bit easier to see, well, when I apply the derivative as an operation, what happens when I have a scalar times a function? Well, what we get is the scalar chills outside, and then we take the derivative of that function, r prime of t, minus 2, same thing. The derivative splits over addition and subtraction, right? So we're able to just take the derivative of each of these functions. We don't need the product rule or the chain rule or anything like this. So this is applying these two rules of scalar multiplication and splitting over addition to get w prime. And then you'll be just substituting in the definition of s prime and r prime. And again, you're kind of suspending disbelief. You don't know how they were gotten, but that's okay. Finding an equation for the tangent line at the point here, 1/2 and w of 1/2. Again, here you're going to use the slope because this is the derivative at that value of t equals 1/2. And then you'll also use the location w of 1/2 from the original formula. And then it's saying, all right, let's look at a separate function. Is v increasing or decreasing at t equals 1/2? Well, to know if something's increasing or decreasing, what you want to do is, well, one perspective is to take a look at the derivative. So look at this derivative. It will be similar to this, just the, s prime plus t or r prime. And then see, is the sign of v prime, can you tell if the sign of v prime is positive or negative at t equals 1/2? That will tell you if v is increasing or decreasing, right? Because if the slope of the tangent line is positive, that must mean that the function is increasing there, and vice versa if it's negative. So, and again, you might have to graph this to tell, but I'll leave that part up to you just to kind of give you some guidance with number 12.